the story will be about this topic of towards cognitive hybrid automated IT. So let me start the story. 1993, it was during the fall of 1993. It's the basement of a lab, and it's around midnight, and there is one Indian guy and one Chinese guy suddenly jumping and clapping hands and dancing and jumping all over the place. There's nobody else there. They are doing this, and I was the Indian guy in that among those two people. The other was LC Kong, and we were thrilled beyond words because for the first time in the world we had actually made a machine work. This was an atomic force microscope. It images at close to atomic resolutions. So it's a nanometer angstrom level imaging. It has a probe that scans the surface at that level, and you get a 3D image of what you're looking at. So so we had made, I at that point made a model saying what will be the interaction of the probe and surface at that level, and what are the distortions that the probe would introduce in the image. So image would look good, but what are the distortions introduced by the probe? And can you then model those distortions, and then can you correct for those and get the original image? So how do you test that at that level? So LC Kong is a nanofabrication guy. He had spent many weeks and weeks creating very known structures and at that level. And then we had put this in the microscope. I already had images of how it should look like, and we had these very strange surfaces, and they had looked like crescents, and I had predicted a certain thing. And after many hours of struggling to make that instrument work, we found that the images looked just like what I predicted. And nobody had done that at that level. And then we could correct and get back to what the structure he had actually developed. So this is, it was a very thrilling thing because it was at that level. It was dealing with images, it was dealing with data, and dealing with the new mathematical morphological techniques applied at that level, and getting those results. So this was, so why were we so thrilled? So this was a journey we were on, right? So my journey was to go and see how, and I was doing it. I had started with unmanned vehicles, robotics in 1991 to have a driverless car. That's the research I was working on. But along the way, you never know where it goes. This very new technology was emerging that could image at the atomic level, and that's what we were doing. And so in that experience in the basement, what I realized was it's all about being dedicated to the problem, believing that there is a problem to solve and really putting all your heart and soul behind it, and also collaborating with other people who you need help with. There's no way I could have gotten to that without a semiconductor fabrication expert collaborating with me and having another world's best person trying to do that, and then working with them and saying, okay, let us make this happen. So a few years later, let me give you another story. Now we are in a truck in the back of a stadium in Hanover, in Germany, and there were three of us, and this was the most thrilling moment of our life. It beat what I just described. This was fantastic. We were so thrilled to speak. One was Yves Jean, the other one was Agata Opalak, and the third was myself. And for the first time in the world, we had over world television tracked a tennis match with 8 cameras around the stadium. These cameras were looking at all the activity that is going on, automatically tracking how the players were playing. This was when? 1997, 1998, right? And we were in real time tracking how the players were playing. We knew every player. The match that had just concluded was the World Championship match between Pete Sampras and Andre Agassi, and at the ATP finals, ATP Tour finals. And we knew every point of the match, how each one had moved. We could get the whole aggregate of what was happening. We knew where they were playing, when they were losing, how were they playing, when they were winning, how were they playing, how were they changing strategy, how did the speed of the players change. And we tracked the ball in real time in 3D throughout actually we were not throughout the match. At that point we were tracking for every serve. So for every serve we knew the exact trajectory, and we knew where it landed. So we knew when so for example, we knew that Agassi was hammering Pete Sampras' backhand. Every serve was for his towards his backhand. So we had things like that. And for the first time in world television, all this had come up with visual graphics in real time during the broadcast. And it was showing every serve, how it was landing, how it was taking off, what was there, this spin in the second serve, all these things you could see in real time. And as you know, this has become a standard in sports broadcasting today, whether it's tennis, cricket, or all this. So that was a fantastic moment, right? And it was three of us. There was a graphics programming expert, two of them actually, Yushan and Agatha Opalak. There was this 3D visualization expertise from Agatha, and there was all this machine vision technology that I was responsible for that made this happen. But it was not just that. It was working with the entire, this project was so much more about understanding how TV broadcasting works. It worked with the entire TV crew, with all the way from how we work with stadiums to set up cameras, how do you wire the entire environment, how do you deal with the lengths of cables and the differences in cable lengths when you want to get 3D and real-time synchronization at that level. So these were the problems we were dealing with, right? So that was a very thrilling moment. And again, it showed that if we wanted to be the best in the world, you needed to give your heart and soul to it. You have to embed yourself in the real world. In this case, it was the stadiums. This was after a year of going around stadiums and following the players and being in broadcast trucks and wiring up stadiums. In the morning, we would have breakfast with the best players in the world in 5-star hotels. During the day, we would be in the back of the stadium in this truck, and the tennis stadia became the real world labs, right? So go forward a few more years. Another very exciting moment. For the many people don't know this. This was around 2005, and we were in the Aberdeen Proving Ground. This is military ground close to Washington DC, and a team of about 20 people are there. A team of 20 people, and I had the privilege of leading this team. We were from 4 institutions: IBM, MIT, Georgia Tech, and University of California. And we, again for the first time in the world, we had put together unstructured data and mobile devices and server computing, what you would call cloud today, and at the time it was not called cloud. We had put all this together in a very unique setting. This is something we had applied to, we showed that we can apply to many other contexts, but these were electronic chronicles that we were developing in real time. So what happens, this is what just happened is, there were many soldiers, because this was the time when there was a lot of activity going on in terms of Iraq and Middle East and so on. These soldiers were dealing with very challenging conditions in a culture they didn't know, in a language they didn't know, and a lot of the things were, you go into a civilian setting and there are so many dangers going on. So this had groups of soldiers going into realistic settings which are all set up there. It was like you were in that country, you were in those environments. There were people of different types, huge crowds. These soldiers were going about with mobile devices. The mobile devices at that time, right? And iPhone had not yet come. And the kind of data we were tracking, from every soldier, we knew their state in terms of how they're moving, are they sitting, standing, or through the talking, walking, running, all those kind of parameters. About the environment in real time, we were detecting first through images and video all the faces, all the cars, all the license plates. We were getting, if there is a face that people in their database, that face appearing again, is there somebody that you need to worry about in that huge crowded environment? It was tracking, it was detecting speech and which language people were speaking and which dialect of language people were speaking, and keywords in terms of, is there anything that we should be concerned about, right? So all this data was, some of the processing happens on the mobile device and a lot of it happens in the back-end cloud. But in real time, from groups of soldiers, somebody sitting in kind of a command center could get an electronic chronicle. They can see the whole journey of every individual soldier and what they were seeing and what they had experienced, and replay and see these kind of things. Or they could take a group of soldiers and get the aggregate and get the entire aggregate across the whole battalion. So it is chronicles at different levels, all composed, and being able to browse all of these. So again, we had various metrics in terms of what we should achieve in terms of accuracy, in terms of the kind of things we should detect, and we had reached a milestone that nobody had made before. And this was a milestone in terms of how we were doing this kind of unstructured data and bringing all this together in real time. And so again, you can imagine, I already told you the institutions that were involved and how much work and how much collaboration and how much embedding of ourselves in the real world happened, and continuously pushing the boundaries of technology, working with data, trying our algorithms, continually improving them, and looking for how can we do the best. So that is what was driving us, right? And so that's another story. So few years forward, let me go to this was around 2012. Actually, 2012, 2013. Big milestone. I was with about 100 people, and in a lab in Bengaluru, India, and we were celebrating because we had reached a big milestone, and we had reached this milestone of driving $1 billion of revenue with cloud computing across clients across the world. So this was a very significant moment for several reasons. Now, I had spent more than about 20 years in the US. I had been working and had this constant striving for being the best in the world and driving game-changing innovation, world-changing innovation. But now, I had returned to India, and it's already been a few years in India. And I came back to India with this same passion, with this same drive and vision that we should be the best in the world. The same thing that took me there to the US, and I had spent at the Artificial Intelligence Lab in Michigan. I had spent time at Bell Labs, hobnobbing with the makers of Unix and C and the first laser and the first microphone and the first telecommunication satellite and so forth. I had gone on to T.J. Watson Research Center, worked with the best people there. I've been having the privilege of doing all this and working with the best in MIT and so on, and driving innovation. The same thing had brought me back to India. Why? Because it was becoming clear to me. In 2008, every year we do something called the Global Technology Outlook at IBM Research, where we look at what are the game-changing trends that are happening in the world. And in 2008, I could see clearly, being part of the Global Technology Outlook, that a tsunami is going to hit the IT industry, which is cloud computing. That was one thing that was clear, and that was going to be hand in hand with mobile. And if I looked at mobile and cloud and what this is going to do and how it is going to change, and I saw what was happening in the IT industry, I felt the action was really in India. Because India increasingly has become the IT delivery, and now it is definitely the IT delivery capital of the world. It is the hub of the world for IT delivery. Today, enterprises, you take the S&P 500, the Dow, the top enterprises around the world, the backbone of their enterprise is being run from India. All the IT management is being done from India. Whether it is banks, or airlines, manufacturing, retail, transportation, insurance, take healthcare, education, every industry is being transformed by IT, and the operations of IT is being done from India. So my experience clearly told me that if I had to do game-changing work, and if I had to change the world, I have to be embedded in data and in where the action really is in the real world. So it was clear that this entire action was shifting largely to India. And then this whole IT model for the world was changing, and it was becoming this model of cloud computing. And so I wanted to be driving that revolution and doing it from India, and that's what brought us here. So it has been a startup story. Time and again, my story has been one of, as I sought innovation and impact, of doing startups. Several startups got spun off from my work. I was on the verge of leaving and doing a startup myself, but at the end I had the startup happen without me moving to it. But it's in an enterprise, whether it was Bell Labs, whether it is IBM, there is huge opportunity. In fact, people who succeed are the people who have this startup attitude. So for me, the startup story in IBM has been tremendous, and this, what I was talking about in 2013, was one huge milestone there. Because I was in IBM research here, and then I said, really I will transform our technology services business. And it was really clear that our technology services, which is like a backbone of the world's economy, it is going to be transformed by cloud computing. And cloud computing, there was a lot of talk going on, but it has to be made real to real clients. So I said, we have a cloud center of excellence. So I put up a board. We are the cloud center of excellence. And there were 3 of us. Me in research, I had one person from and 2 people I had borrowed from the IBM Systems group. And we declared that we are the cloud center of excellence. So we started going for 6 months. We went and did a lot of work. I had funding to support the three of us, and we went and worked with a lot of clients and a lot of teams. So it was okay, decent progress. But then one very interesting thing happened, just giving you another side of this. My boss at that time said, 6 months I have funded you, now the honeymoon is over, I can't give you funding anymore. You have to survive on your own. I had never been in that situation. I always had, I was a blessed researcher getting top class funding. So I said, okay, so what do we do now? So I said, there's only one thing we can do. We have to go and deliver value, and if people see value, they will pay me, right? So I started working. So in these first 6 months, being in India, I had worked with a lot of Indian clients and Indian teams who were always willing to humor me, and and we would go and talk and we would do something, but nobody was really, it was not going anywhere to the next level. But now the moment we changed to this stance, I suddenly found I had to take the clients who are most interested and for whom this was most critical. Suddenly I found myself going all over the world, because I was dealing with clients in Europe, I was dealing with clients in Australia, I was dealing with clients in Latin America, and of course in the US, and one or two in India. And within a couple of years, this is the milestone that I was talking about, we had hit $1 billion of revenue. We were working with over 200 clients across the world, and our team had grown to 100. Right? So that was a huge milestone, right? And but what was this? And then the next thing I would talk about is 2016 October. This was, and Narahari is here as part of that milestone. We were very thrilled because the biggest business of IBM is Global Technology Services. It's about a $30 billion business, and the head of that business, Martin Yetter, had come to a couple of kilometers from here to open the Global Technology Services Lab, right? Global Technology Services Labs, and we had inaugurated that, right? And so we became the technology development unit driving all technology leadership for this business. And this is a worldwide team across 20 plus countries, with the center of gravity right here, 2 kilometers away, and the leadership from here. And so that was another tremendous milestone. And so, few minutes, I'll talk about what we do, right? So it's all about our mission and vision is to transform enterprises all over the world with cognitive hybrid automated IT. So we do, one huge part of what we do is automation. We are running the infrastructure for many hundreds of enterprises all around the world, and we have thousands and thousands of people managing and doing this work. So our aim is to increase speed, increase time to value, increase quality, increase reliability, increase security. For all these reasons, automation is critical. You cannot depend. When you want businesses are transforming all over the world. They have to be 24/7. Everything is being driven by the digital transformation that Samir has talked about. And in a digital world, and you have seen this, right? Whether it's your internet banking, whether it's your retail, whether it's how you're doing shopping today, everything is human-centered, consumer-centered, available anytime, and all driven on the internet. The default model for that is cloud. You have to have a cloud infrastructure that's elastic, scales up and down, and scales to the peak volumes that people have. At the same time, it is able to run in the internet, get all the data from the internet, process it, and have the intelligence about what people are doing. And at the same time, have the enterprise, private, secure, largely confidential data on the premise, all this coming together in a hybrid model. And in a world that is changing with many providers, whether it's you have Amazon or Azure or IBM Cloud or Google Cloud, and people want to use, enterprise want to use all these clouds, you should be able to combine all of them, bring all of it together, and give you a unified view. And all of these needs to be integrated, all of this has to be managed, and all of this has to be automated, and in a very secure way. So that is the challenge, right? And so that became what we are doing. In a world of hybrid, it is a given that there is the traditional data center, there is the on-premise cloud, off-premise private cloud, and off-premise public cloud. All of this has to come together. And the oil is data, as Samir said, right? So everything that is happening at a human level, whether it's in the service desk, what problems are people answering, what are they doing, what records are they maintaining, structured, unstructured, the logging of every machine, of every transaction, that has to be collected. So the heart of all of this is a data lake. A data lake that, in the case of IBM and what we are doing with GTS Labs, is a data lake like no other on the planet. So that is nobody has this kind of an enterprise data access and the kind of data lake that we have, combining 180 sources and some of the data going back 30 years. So we know the kind of data is unprecedented, unparalleled. So how do we then take this data coming from a hybrid cloud, analyze it, have the analytics and AI, and give you real-time visibility to your entire enterprise operation? From what are your critical applications, what are your critical business processes, what are your infrastructure level operations, and giving you one view of all of this, and being able to say, here is where I need to focus my attention on if I have to keep my operations 24/7 up and running and at the scale that I want to meet my consumers' needs. This is what every bank is thinking, every healthcare industry is thinking, retailer is thinking, insurance industry is thinking, manufacturer is thinking, and so on. So that's what we are providing. And today we have made great strides. We run 1 million automated operations every week. This is like operations include, if there's an incident, it's automatically resolved. If it is a compliance has to be maintained. Security is one of the biggest concern in all this, right? So if you want to make sure that your entire enterprise is compliant, that every server is at the right level, following enterprise policy, no server is out of compliance, that every patch is applied and all systems are on time, and you want to look at the entire end-to-end process and say, how is it optimized? Those are the kind of things that we're doing. And 1 million today, and with the exponential growth, I expect this to grow to a few million already by next year, right? So that's one big thing that is happening now. So what happens as a result of this? One is end-to-end visibility. The other is automated resolution when there is a problem. And the third is prediction and prevention. So these are the waves we are going through. First is visibility, because you need to know what is going on in this very complex environment. The second is when there's a problem, it's automatically resolved. But then the third level is you want to anticipate the problem before it happens. And this is what we're doing with predictive insights, right? And this is very interesting. Just 2 days ago, a major client of ours, which is a major European bank, wrote in their newsletter how they have reached, how everybody is seeing the effect of AI in their IT operations. And they were calling it, we had an AI moment, because we saw before a problem happened, a week ahead, we could predict that this problem is going to happen. This was based on data that we were having before, and we could warn and prevent it beforehand. So this AI is becoming real for everybody, even in the IT space. So these are some of the examples, and let me step back, and if I talk about this whole journey, there are some key messages, right? One is really, it's all about innovation, it's all about passion, and it's about being the best in the world. And for me, this startup now that we're doing is now over 1,300 people, and now close to $10 billion of impact. And this is the kind of thing that we're doing, and the journey has only begun. Because there's so much more ahead. Because we are in a world, throughout this journey, for me, it was a journey in data, AI, and unstructured information. And that journey has been, and another statistic from Sameer's talk, 44 zettabytes of data by 2020. And it was just a few years ago, 4 or 5 years ago, it was 4.4 zettabytes of data, right? And it's 44, and it's going to be 440 in just 4 or 5 years, right? And the rate at which this is growing, that's why I say we are at the beginning of the journey. So which means, who will lead, who will dominate this space is a huge open question. Whether it is companies, whether it is countries, or whether it is individuals. And for all of you who are getting into the analytics and security program, by the way, security is, as I've been saying a few times, is huge for us. It is the biggest thing that I am dealing with. While the passion is all about AI for me, a lot of time is spent on security, because that is the biggest threat we have in the world today, and this is the biggest thing that keeps CEOs, CIOs, CTOs awake at night, because they don't know when a cyber threat is going to annihilate them, right? And so it's a constant battle. It is driven by data, it is driven by AI, it is driven by cloud, because you can't get that level of data and scale and the ability to deal with security threats that you have with the same cognitive hybrid automated technologies. So this is huge for us. And as a DevOps organization, it is something that we embed across the whole DevOps lifecycle. So security is paramount. And one of the biggest initiatives we have right now is cyber resiliency. We've been doing a lot of work in disaster recovery, in backup as a service, disaster recovery as a service. How do we do that in the wake of a cyber incident and automatically ensure resiliency in the wake of cyber threats? So that's one of the biggest things we're dealing with. But coming back, this world, this opportunity, the story that I have been on is the story of all of us. It's about how we innovate, how we drive with passion, how we be the best in the world, and how we drive change and be game changers and be the leaders in the world. I think that is the passion that led us to form the GTS Labs with 1,300 people. This is the passion I see when I go to a lot of places. And in the Indian context, let us switch to the Indian context now. I saw one thing I was missing in Sameer's talk was none of those examples were from leading from India. So if I look at AI conferences, and I run IEEE Cloud Computing and Emerging Markets Conference, this is the 8th year of the conference. We have been driving that to drive innovation and leadership, especially from India and the emerging markets. So there's a lot of progress, but if you look at the top AI conferences in the world, take AAAI, 80% of the papers now, 80% are from China. Not just from Chinese people in the US, they are from China. So there's a huge question that you should ask yourselves as Indians about how you're going to lead in this era of 44 to 40 to beyond zettabytes of data when still the game is very open. Are you going to dominate and be the best in the world? Are you going to have the mindset to say, whatever I do will be world class and it will be game changing and I will be based, and you have all the access? When I went to Michigan in 90, I had to go to a place like that to get access to the computing or to get to the data or to get to the expertise. Today, it is child's play. I'll give you 3 quick examples. Where we had a young boy. 3 years ago, I was at the IBM Interconnect conference, which is the biggest conference at Las Vegas with about 20,000 people in the audience. And there was a 11-year-old boy who addressed and gave a keynote much bigger than the one I am giving now to 20,000 people in a stadium-like setting with all these people across the world, because he has his own YouTube channel in AI, he has developed algorithms, and he has developed a training system, and he addressed these people. In my own personal experience in the cloud computing emerging markets, 2 years ago, a girl talked about the work, I can continue, about the work she was doing on the lakes of Bangalore, and the water, takes it in real time to a cloud, gets the data, and gives you information about what is the status of the water, and also gives recommendations on what are similar lakes with similar problems and what steps you should take to remedy them. And this included, so that's another example. I know, and this is a high school student, right? And another high school student presented at the Cloud Computing Emerging Markets Conference. Again, we accepted only 8 papers for oral presentation from many hundred papers, because very high standards, right? And one of those papers was from a high school student called Plant Doctor. And he was using, again, a camera and a mobile app. You could take a picture of your plant. It would automatically take the data, do the analysis, do the meta-analysis, compare it with all the other things, give you recommendations back on what disease or problem your plant may have. This is for farmers, and like the Japan example Samir gave, but this is again a high school student in India doing it with Indian farmers and giving this app and making it work. And all you need is a mobile camera, and everything is AI in the cloud, and then you're getting back advice on the ground in a way that the farmer can understand. Another example, there's brushing. So one girl I know in high school came up with the idea that, okay, very personal. She was seeing that her sister had 3 teeth extracted at the age of 5, and she said there's a lot of problems with brushing, and then can I do anything about it? And she went and talked to dentists, talked to doctors, found actually that mouth is the index of the body, and that there is so many diseases that have oral manifestations, and besides dental problems. She said, so why don't I create a device that will help anybody at home monitor their teeth? Because anybody, they have to brush. If I give something like a brush in their hand, it fits in their daily routine. So she, using a Arduino Nano, and camera, a breath sensor, and a temperature sensor, and accelerometers. She combined all of those into a brush-like device. Put the high school student, right, and using 3D printing, designed that thing and designed that brush and printed it out and put all that electronics in there. Then it takes images. She used Google TensorFlow and Big ML. So she has basically this thing. You can do a scan of your mouth. It sends the data using a mobile app to these things and gets the. It tells you if you have cavities, if you have gingivitis, if you have I think it's called halitosis or something like that, bad breath. And this is only the beginning, right? So suddenly you have something that creates data, and it is taking a step beyond just telling you if you have brushed or not, right? It's giving you a lot more information. That's a high school student doing it. So my message to all of you friends is, today the possibilities are unlimited. The technology is available to everybody. The world is the lab. The cloud is your computing system, and AI is available to everyone. So there is no limit to what you can do. You have to think of being world leaders and dominating the world with technology. That has to reflect, in my opinion, in 3 ways. One, you are master students now. You should think of producing world-class research papers. They should stand up in the best conferences in the world and be really game-changing research papers that anybody would stand up and say, this is a world-class research paper. That's what you should aim for. Second, you should think of startups. You should, India and Bangalore ecosystem is tremendous. You should connect to this ecosystem. You should produce game-changing, wealth-generating, world-class startups from here, driving new products. And third, India itself is a huge market, huge. Its problems here are unlimited, and which means the opportunity is unlimited for all of you, because the problem is an opportunity for the person who looks at it. Necessity is the mother of all invention, right? So there is, we saw how children are attacking these problems, and there's no limit to what you can do, and it will make difference to millions of people right in this country. So that's the other thing I think you should aim for, and then we can all be proud of what you're doing at REVA. And today, if high school students can do it, if children all over the world can do it, certainly master students at REVA can do it, and they can compete with the MITs, the Stanfords, and the other institutes of the world in terms of the best work you can produce from here. So wish you all the best and go for the best. Thank you.